Hello friends, we are going to learn about the topic components of OpenStack Cloud Architecture, in which we are going to learn about the components of OpenStack Cloud Architecture. That means the compute, storage, networking, dashboard, etc. Components of OpenStack Cloud Architecture. What is the definition of OpenStack? We all know what OpenStack is, how it works, what are its features, what are its architectural requirements. Now, what is exactly the definition of cloud computing architecture, OpenStack cloud computing architecture? So, OpenStack is open source cloud software which consists of a series of elite projects controlling large pools of computing, storage and network resources in a data center while managing through a dashboard. It is designed to run on commodity hardware such as ARM, also we frequently call as ARM, and x86. OpenStack has grown into a large community with over 9,000 contributors and nearly 500 companies since its initial release in 2010. That means OpenStack came into existence in 2010 by NASA and Rackspace OpenStack.org released it under the Apache license 2.0. That means this thing came into existence in 2010, launched by NASA and Rackspace OpenStack.org, and it released under the license Apache 2.0. So why it is used? It is used, or it is created, or what it controls a complete large pool of resources or large pool of this computing, large pool of storage, large pool of networking. That means it has pools of different technologies or requirements or physical resources, and then it creates projects and then controls it in a data center while managing it through a dashboard. Now dashboard acts as the user interface to that particular resources internally. OpenStack helps the business run faster and delivers cost-effective infrastructure to manage data analytics, transactions and business applications. This is the overview of OpenStack Cloud Operating System. How does it work? We have this standard hardware in the first layer, then we have this OpenStack shared services in the next layer, and after that we have the upper layer of this OpenStack shared services. We have this compute, networking and storage. These all run with the help of this OpenStack dashboard which is there, and the application which we create on cloud runs with the help of the APIs, because APIs communicate through these resources and make this run or work for the end user or the clients. OpenStack components. See, OpenStack consists of multiple components with a modular architecture and various code names. Let us have a brief look at the components of the OpenStack. What are they and how they work? Why they are useful? First comes compute. The component for compute is Nova. So, OpenStack Compute is a cloud computing fabric controller which manages pools of computer resources and work with virtualization technologies, bare metals and high performance computing configurations. Nova's architecture provides flexibility to design the cloud with no proprietary software or hardware requirements, and also delivers the ability to integrate the legacy systems and third-party products. Nova can be deployed using hypervisor technologies such as KVM, VMware, LXC, Zen Server, etc. It is used to manage numerous virtual machines and other instances that handle various computing tasks. See, now as we all know what compute is. Compute means doing the computational task for any of the resources. So what this particular OpenStack compute do? It is a kind of a fabric controller for this particular cloud computing in OpenStack. So it manages what it manages. It manages the computing resources. Computing resources. What are these computing resources? That work for the computational operations, and it works with virtualization technologies such as hypervisors and etc. Then bare metal is considered to be a type 1 hypervisor which helps in virtualization or creating virtual machines for the resources or physical underlying hardware. And high performance computing configurations. Now Nova's architecture provides the flexibility. It provides the flexibility to the user or to the particular operator to design the cloud with no proprietary software. That means this Nova do not require any of the proprietary software. It gives the, since it is an open source, so it gives the user the flexibility so that it can design as it want. It can customize as per the requirement to specific things it wants. And the hardware requirements are also not mandatory that particular thing should be have particular hardware or that composition or configuration is needed. It can be as per the usage or the requirement of the client. And also it delivers the ability to integrate the legacy systems. Now legacy systems means the systems in which the enterprise is already working plus to the contemporary. That means at moment what systems are there, so it can comprise, it can create a combination of both, and then it can work, and it can also work on the third party products as well. See, it can be deployed using hypervisor technologies. Now what hypervisor technologies? Usually it uses KVM, it uses VMware, then LXC, then Zen server, etc. So it is used to manage numerous virtual machines. Since we all know with virtualization we have a pool of hardware or physical resources, it is being virtualized and created virtual machines. There are multiple virtual machines, or it can manage numerous virtual machines as well, and other instances that handles various computing tasks. Then another component for OpenStack is Glance. Now Glance is used for image services. OpenStack image service offers discovering, registering, and restoring virtual machine images. Glance has client-server architecture and delivers a user REST API, which allows querying of virtual machine image metadata and also retrieval of actual image. While deploying a new virtual machine instances, Glance uses the stored images as templates. OpenStack Glance supports raw, VirtualBox VDI, VMware. It has VMDK, OVF, then Hyper-V, VHD, and QEMU or KVM, QCOW2 virtual machine images. That means these all virtual machine images can be used or deployed in this particular component of OpenStack. So what this Glance do here now? Image services, what kind of image services are present there? OpenStack image services, what it offers? It offers the discovering, registering, restoring of the virtual machine images which were there. That means existing virtual machine images which are there, you can restore it, you can discover it, that if it is there, and if it is there you can register it, or the new virtual machine images can also be registered into it. Then you have this Glance. It has the client and the server architecture. So we all know how client server architecture works. and it delivers the things using the REST API. That means, as we all know, REST API, anything can be accessed and issued using this API in cloud stack architecture. So it deliver a user REST API, then which allows querying of virtual machine images metadata. We all know what metadata is. Metadata is data of data. So this virtual machine image metadata, user or client can query where these images are, and it can search it amongst the database, and also retrieval of actual image. Now you have the virtual image, you are getting it, the replicated image, mirror image, etc. But it can also help you to gain access to the actual image of that information. While deploying new virtual machine instances, here glance, it uses the stored image as templates. That means you can restore or you can store your image into the database using these templates. Now OpenStack glance, what kind of images it supports. So it supports this raw images plus VirtualBox images. VirtualBox provides VDI for the cloud, VDI images for the cloud. Then VMware, it provides VMDK and OVF images for the cloud. Then Hyper-V, it provides VHD and QEMU or KVM, it provides QCOW2 virtual images or virtual machine images for the users or the clients. Then comes Swift. Swift is for storage, and specifically it is for object storage. OpenStack Swift creates redundant, scalable data storage to store petabytes of accessible data. The stored data can be leveraged, retrieved, and updated. It has a distributed architecture providing greater redundancy, scalability, and performance with no central point of control. Swift is a profoundly available, shared, eventually consistent object store. It helps organization to store lots of data safely, cheaply, and efficiently. Swift ensures data replication and distribution over various devices, which makes it deal or ideal for cost-effective scale-out storage. See, now what we all know, storage type in cloud architecture, it is of three type or several types can be there, majorly used in three categories. One is object storage, the other one is block storage, and then the file based storage. So Swift is object storage type, first thing. Now how this OpenStack Swift helps, it creates redundant means multiple copies of the same data or information. Then it has scalable data storage to store petabytes of accessible data. That means scalability is one of the feature of cloud computing or one of the quality of service parameter of cloud computing. So it provides scalability of data storage, and you can store petabytes of data into that type of storage, and you can access it with this particular Swift. The stored data can be leveraged, retrieved, and updated using Swift or in Swift data type. Then it has a distributed architecture. We all know cloud computing is distributed databases over internet. It uses distributed databases over internet and gives the accessibility to the clients. So it has a distributed architecture. It provides greater redundancy of the data, scalability, and performance with no control or no central point of control. That means it can have various points of control for that information. Now Swift is profoundly available, then it is shared, and eventually it is consistent object store. It helps the organization to store lots of data. See, we all know scalable data storage is provided by Swift, and we can store petabytes of accessible data in Swift. So it is provides or it helps the organization to store lots of data safely, plus the cost is less, that means cheap, and efficiently. That means since it is accessible data, you can access the metadata as well, so it is efficient. Then Swift ensures data replication. Data replication means mirroring of data and distribution over various devices, which makes it ideal, or which makes it a great deal for cost effective and scale out storage. Then comes the dashboard. Dashboard, or we could say Horizon, is the component for OpenStack cloud architecture. So Horizon provides user interface, or it acts as dashboard for the users to use or to get into the OpenStack architecture. Horizon is authorized implementation of OpenStack's dashboard, which is the only graphical interface to automate cloud-based resources. To service providers and other commercial vendors, it supports with third-party services such as monitoring, billing, and other management tools. Developers can automate tools to manage OpenStack resources using EC2 compatibility API or the native OpenStack API. Now, as we all know, Horizon is user interface in cloud architecture. So, what user interface provide, or what is the use of dashboard? Dashboard is the only thing, as mentioned here, the authorized implementation of OpenStack, which is the only graphical interface to automate cloud-based resources in OpenStack architecture. Now here, to service providers and other commercial vendors, it supports with third-party services. See, since dashboard is there with the architecture, as we have seen in the diagram, there is one underlying hardware architecture. Then we have this OpenStack layer. Then we have compute, networking, and storage in OpenStack, and it is connected with the API with applications of the client and also with dashboard, OpenStack dashboard, and it works in that way. So this dashboard, it acts as third party for this application of the end user or the clients, such as monitoring, billing, and other management tools can be managed with the help of this dashboard or Horizon component. Developers, they can automate tool to manage OpenStack resources using EC2. EC2 is Elastic Compute Cloud Compatibility API or the native OpenStack API. As we have seen, see, EC2 compatibility API or the native OpenStack API. So here, this API which connects to this complete architecture of the OpenStack can be either this Elastic Compute Cloud API or Compatibility API or the native OpenStack API. Then comes Keystone, the another component of OpenStack architecture. It is identity service, or this component provide identity service, which is the major point of concern when it comes to security of the information or data stored in the cloud computing. So Keystone provides a central list of users mapped against all the OpenStack services which they can access. It integrates with existing backend services such as LDAP, that is address protocol, local directory address protocol, while acting as a common authentication system across the cloud computing system. Keystone supports various forms of authentication like standard username and password credentials, AWS style, that is Amazon Web Services, logins, and token-based systems. Additionally, the catalog provides an endpoint registry with a queryable list of the services deployed in an OpenStack cloud. See, these things, that means the identity service, as we all know, is the major point for security in OpenStack cloud architecture. We have seen in the features. So this component, that is Keystone, it provides this identity service. How does it do? it provides the central list of users who are using that particular resource or service, then mapped against all the OpenStack services. That means since there are, for say for example, 1 2 3 4 5 users are there, so this Keystone, it has provided the list of the users. Now they are being mapped with the services, say for example A, B, C, D and E. All these services are there provided by the OpenStack. So now they are mapped against services. That means, say for example, user 5, it is using 3 services, then user 4, it uses 2 services, user 3, it uses, say for example, 2 services, user 2 uses 1, and user 1 also uses 1 service, or all the 5 services, you can say. So it is mapped against the OpenStack services which the particular user can access. So it integrates with existing back-end services such as LDAP while acting as a common authentication system across the cloud computing system. Here, Keystone supports various form of authentication like standard username and password. It is one form of identification of any of the user who is getting into the system. Then AWS style logins and token based systems. Additionally, the catalog provide an endpoint registry with a queryable list of the services that is deployed in the OpenStack. So it has various forms of identification of any of the user who is accessing the services, so that it can use, like we enter into the Google services or we use any of the email services. Say for example, in Gmail we use the username password. For the social media services we use the username and password, and then it can have something like token based systems also. So there can be various levels of identification which can be there and provided to the users to access the services in the cloud computing architecture in OpenStack. Then comes another component, that is Neutron. Neutron is used for networking. See, Neutron provides networking capability like managing networks and IP addresses for OpenStack. It ensures that network is not a limiting factor in a cloud deployment and offers users with self-service ability over network configurations. OpenStack networking allows users to create their own networks and connects devices and servers to one or more networks. Developers can use SDN technology to support great levels of multi-tenancy and massive scale. As we all know, what networking capabilities are required in any of the cloud architecture. With the help of this networking, they should be able to manage the networks and IP addresses for the particular infrastructure on which it is working. So Neutron, being the component of OpenStack cloud architecture, should be able to manage, or it should have the networking capability to manage the networks and IP addresses for OpenStack. Then it ensures that the network is not a limiting factor in a cloud deployment, and also it offers users with self-service ability over the network configurations. OpenStack networking allows users to create their own networks. That means the end users which is using it, they can create their own network, and it can connect devices and servers to one or more networks. Now developers can use SDN technology, which supports to a great extent, and also another kind of technologies, but SDN technology is more dominant into it because it supports multi-tenancy and massive scales of, that means the levels of connectivity will be massive in that particular technology. That means scalability will be massive. Neutron also offers an extension framework which supports deploying and managing of other network services such as virtual private networks, firewalls, load balancing, and intrusion detection system. Intrusion detection system, that means any hacking or intruding into that particular system. Then comes another component, that is Cinder. Cinder helps in block storage. OpenStack Cinder delivers determined block storage or block level storage devices for application with OpenStack compute instances. A cloud user can manage their storage needs by integrating block storage volumes with dashboard and Nova. As we all know, what dashboard provides? User interface. What Nova provides? Compute functions or computational functions in the cloud architecture. Now we know storage is of multiple types. Swift provides object storage. Cinder, that is, and it provides another type of storage, that is block storage. So how block storage is provided? OpenStack Cinder, it delivers determined block level storage devices for the application with compute instances in OpenStack. So a cloud user, they can manage their storage needs since they are provided in block storage volumes. So these volumes can be integrated with the OpenStack dashboard as well as Nova to compute or communicate. Cinder can use storage platforms such as Linux Server, EMC. EMC provides block storage volumes like Scale Input Output, Vmax and VNX. Then Ceph can also be used, Coraid, CloudByte, IBM, Hitachi Data System, SAN Volume Controller, etc. It is appropriate for expandable file systems and database storage. That means it provides scalability as well. Then comes another component, that is Celiometer. Celiometer provides telemetry. Celiometer delivers a single point of contact for billing systems, obtaining all of the measures to authorize customer billing across all OpenStack core components. By monitoring notifications from existing services, developers can collect the data and may configure the type of data to meet their operating requirements. Then comes another component, that is Heat, orchestration. Heat is a service to orchestrate multiple composite cloud applications through both the CloudFormation compatible Query API and OpenStack native REST API using the AWS CloudFormation template format. Though OpenStack is made up of several other components because of its open nature, the OpenStack community has recognized these 9 components as the core components. OpenStack will help the business in accelerating the time to market, integrating with a variety of key businesses, and delivering the most value from the cloud. So enterprises need to consider the building of their cloud platform with OpenStack. VM or vMoksha specializes in providing cloud-based services including OpenStack. Thank you.